elimizde bulunan ligniti bizim ülkemizdeki lignitlerin kalitesi çok düşük. Antrasitin kalorifik değeri 7000 kalori iken bizim ülkemizdeki lignitlerin değeri 2000 ile 3000 kilokalori arasındadır. Bizim bu projeyi yapmamızın amacı petrol ve doğal gaz rezervleri giderek azalmakta ve pahalanmakta. Biz bunun yerine ülkemizde bolca bulunan ligniti kullanmak istedik. Bunun için de ilk önce aldığımız ligniti yarı koklaştırdık. Yarı koklaştırdığımızda lignitin değeri ilk başta 5877 kilokaloriydi. Daha sonra yarı koklaştırdığımızda 6396 kilokaloriye kadar geldi. Daha sonra biz bu yarı koklaştırdığımızda içindeki pirit normalde manyetik bir özelliği yok ama bu 400-500 santigrat derecede ısıtıldığında içindeki pirotine dönüşebiliyor. Bu pirotinin de manyetik özelliği var. Biz bunu kullanarak ilk önce bunu ısıttık, daha sonra manyetik ayırıcıya soktuk. Pirotine dönüştüğü için manyetik ayırıcıda 3 tane madde elde ettik. Bunların biri ana ürün, en iyisi. Ana üründe kalorifik değer 5877'den 6727'ye kadar yükseldi. Hem de daha temiz oldu. Yani zehirli atıklar içinden atıldı. İkinci maddemiz ise ara ürün. Bu ara üründe yine ilk niyetimize göre daha temiz ve daha kalorifik değeri daha yüksek. Bu ise atık madde, en son kalan madde. Bu kül, bu yani hiçbir kalorifik bir değeri yok ama bu yine de asfalt yapımında kullanılıyor.
Bizim amacımız her gün kullandığımız tuzdan bir charge bulmaktır. Bizim eksperimentte biz 2 tane metal disk alıyoruz ve bunun arasına her gün kullandığımız table salt tuzu döküyoruz ve tuzun üstünden bu metal diski koyarak bunu multimetre ile bağlıyoruz ve multimetre açıyoruz ve bunun üstüne yük koyarak bize bu tuzun charge verdiğini görüyoruz. Bu yükü değiştirerek bize bunun yükseldiğini de görüyoruz. Teşekkür ederim.
I'm from Kazakhstan. My project about receiving of thin films of inorganic scintillators cesium, iodine, and thallium by vacuum dusting and their properties. The interest in receiving and using of thin films of inorganic scintillators as detectors of a nuclear radiation was grown last time. Thin film scintillation detectors had a special meaning during the registration of gamma rays with energies kilo electrovolt amount background radiation. The aim of the given work is the creation of a technology of preparation of the thin film scintillation detectors on the base of activated cesium iodine with a high light exit. In this picture we use vacuum camera and pumped 1200. Vacuum camera was pumped with pumped 1200 chill pressure 305 times 10 power of -5 millimeter of mercury pillar. Several series of testing were made in vacuum 10 power of -6 millimeter of mercury pillar. As you see in the picture, we use the bases from optical quartz with thickness 2 millimeter and diameter 20 millimeter. The base was washed carefully before dusting. First off by organic dissolvents, then with distillatory water. The base was dried by rubbing with natural silk. And factory crystals, cesium, iodine, and thallium were base materials for dusting. Crystals were broken on pieces with weight of 50 and 100 milligram each, and in each cover were placed in molybdenum boat. When current passes through the molybdenum boat, it heats and crystals vaporize to base, rise up to base. And there, if the temperature of the base will 25 Celsius, the structure will be like this, small crystals, very small crystals. If the temperature of the base will 200 Celsius, it will have small crystal structure like this. Size of small crystal increase with the increase of the temperature. In the 300 temperature, in the 400 temperature. As you see, they are very big. The size of small crystals increase with the increase of the thickness. In the first picture, the thickness of film is 1.3 milligram per centimeter square. In the second picture, the thickness of film is 5.2 milligram per centimeter square. And then, if we increase the temperature of the base, the light exit of film cesium iodine will rise, will increase, and in the reaching maximum 200 Celsius, and then it's lowered quickly. With the 300 Celsius, to the significance corresponding to the light exit of the base of inactivated cesium iodine. It is an inactivated cesium iodine. When the temperature of the base will increase, it will increase. And then in the temperature 200 Celsius, it will exceed it primarily in 2 times.
My project is called Lightning Telegraph. It is same like the normal electrical telegraph. It's same like the electrical telegraph, but the main difference is that instead of the electromagnet, here I used lights. So here, in this lightning telegraph, a battery, a switcher or a key, and a diode represent an electrical circuit. Here, in this case, these 2 circuits are opposite, so they're connected in a way that pressing each switcher will will close the opposite circuit. So we can use the signal for communication. So if I press this switcher, the opposite diodes will glow. If I press this one, the opposites will also glow here. So this light signal can be used for communication. We can also invent our own code, our own alphabet, if we're creative enough. And I think that this is an easier, more economic way to communicate. We can use it for communication from one room to another. We can use it for communication with our friends. And that's it.
Hi. This is economic box or battery saver. Here we have, if we do like this, here we have light. But I'm going to show you how this light is made. First of all, we have, for making this, we need 9 resistors, 2 transistors, 3 transistors, 2 batteries, from each one from 1.5 volts, and together they make 3 volts. And then we have 1 capacitor, 1 switcher, and 1 LED diode. Each battery has a plus and minus field. So the minus battery with the wire goes directly to the LED diode. And the plus battery with the wire goes directly to the capacitor, the resistors, transistors, and to the other end of the LED diode. But we should remember that this light is made from the capacitor, not from the batteries, because the batteries fill the capacitor, and then when we do like this, the power goes directly from the capacitor to the resistors, transistors, and to the other end of the LED diode, and it makes light. But when the light is 1.2 volts, then the transistors are working like switchers, and the power is off. So in the time that when we do like this, when it's in this situation, the capacitor is filling with power, and the process is repeating. We can use this. Let's say you're living in a building and you are climbing to the stairs and you switch on the lights, but you forgot to switch them off. So you're going in your apartment and the lights are on, and then the batteries will go off. In this way, there is a certain time when the power is there is power, and then you are saving your batteries. So the usage of the batteries is prolonged, and you save money, time, and nerves. Okay.
Sarzufreta. I'm from Skopje, Macedonia, from private Yahya Kemal College. This is my project called the levitating tree. This is constructed from two main parts, the base and the platform. The base have plexiglass, wood shelving with melamine surface, and magnet tracks which are north facing up. And this is the platform. It's from form core board. Also, it has magnet tracks. As you can see, these are also north facing. And as you can see here, north and north are repelling each other, but south and south are repelling each other. But these are, when they are unlike, they are attracting each other. That is why when I'm putting the platform, these magnets are repelling these magnets, and that is why it's flying and moving very, very fast. These have the same construction with maglev trains, which are one of the latest technologies now. They are moving even 500 kilometers per hour. They are useful because there is no friction force. We're saving energy, and also we are saving our time. That is all.
My name is Junaid. I am from Macedonia, and this is my project called Drinking Pipes Spirometer. People usually go to doctor when they want to know their lung capacity, and there they use a spirometer, which is a machine used for measuring the lung capacity. What with this project called Drinking Pipes Spirometer, we can find our lung capacity without using spirometer, and it will be done in entertaining way. There are some experimental steps, and we need only a pipe, water, glass, and chair. That's all.
Hello, my name is Georgi Pavlov and I come from Macedonia. My project is about air power for transportation. In today's time, energy rises and oil prices constantly rise. So we need to find alternative power to power up our vehicles, to power up our transportation means. So I made a project that consists of air, to use air as such substance that it could propel a vehicle. So I tried with several air containers, in this example balloons, so it could the stored energy that was in the container, the balloon, the air could use to propel itself along the track we have here. So if we do the same system, for example, if we store the air in a gas bottle, a big gas bottle, we could inject it into the engine and then to propel the engine into the engine and to drive the pistons, so we could drive a car that way. And the air has certain limited amount of power, so we could use it if we are several kilometers from the gas station. It could use it as an alternative power solution in our vehicles.
Hello, my name is Ilya Sokolov. I'm from Ukraine, from 7th class. The name of my project is Automatic Trap. Topic is application of electromagnet. The purpose of my project is to catch a mouse or a thief in the house. It works by the making use of electromagnet. My project is made for people who support animal rights. Because you can catch an animal, such a mouse, without killing it or without injuring it. In my project there are two electric circuits. In first circuit there is a switch, a coil, iron core, and 4 batteries which are connected in series. In second circuit there is an alarm system, iron door, and ends. When the mouse comes through the entrance, goes through the tunnel and steps on the switch, the first circuit is completed and electric current passes the coil. Iron core becomes a powerful electromagnet which attracts iron door. When the mouse steps away from the switch towards the fresh cheese, the first circuit is not completed anymore and the iron door falls because of its weight. Makes needed connections for second circuit, and finally the alarm system works and the entrance is closed and mouse cannot go anywhere. For example, mouse steps on the switch, attracts the iron door. When it steps away, the alarm system works.
Our program, the name of our sensor is thermoelectric converting sensor.
The alternative source of energy is increasing day by day nowadays, so we decided to prepare a new model of the system transforming the thermal energy to electrical energy. As you know, in laboratory conditions, electricity is able to be gained by gradient temperature using thermopiers. Let us describe the structure of our model.
Our sensor converts thermal energy to electric energy. Sensor use planar convex lens and thermopiers, which made up of the copper metal conductors. These planar convex lens and thermopiers are placed in special dielectric tube. And there is a planar convex lens on the open top side of a tube, and it's fixed by means of screws, so that flat side is forward to the outside. A snapshot of the black object called lay is located on the focal point of the lens. It's aimed to provide maximal absorption of the beams, which are somewhat on the focal point.
Aluminium mass is situated at the bottom part of the sensor tube. Active ends of thermopiers are joined to up and down to coal and aluminium respectively. Due to the fact aluminium is very big and it emits heat very easily. That's why the temperature remains constant or equal to the temperature of environment. Since the end of thermopiers are connected to the coal layer, absorbs the beams, it's heated. That's why there is a temperature difference between coal and aluminium body. The proportion of to difference between temperature between aluminium and coal body, thermoelectric converter sensor is created.
And let's note that beams coming from the ednescence gather on the focal point of the lens. For instance, beams coming from the sun gather on the focal point of the lens and depends on the intensity of beams showing the millivoltmeter change. So if we carry out observations in different periods of days at 11, 12 or 5 o'clock, we can see that our voltmeter shows different values.